we're going to learn about area and the fundamental theorem of calculus. First, let's talk about the definition of a definite integral. The definition of a definite integral involves the area. So area is going to be equal to the definite integral from a to b of f of x dx. And what that means is if we have a value of a value of b along our x-axis, and we have this function f of x that looks like this curve, then this area that's created from a to b underneath this curve f of x. So let me show you this area right here. This area is equal to the definite integral evaluated from a to b of f of x dx. And this is true when, let me write this over here, when f is non-negative, so when f is non-negative, meaning that the graph is sitting above the x-axis, and it must be continuous. So we can't have any breaks underneath that portion of the curve. So the portion of this curve has no breaks where I've highlighted it in yellow. So it's continuous on that portion of the curve from A to B. I'm going to say one more thing about the area here. The area is going to be bounded, because this language will be important, bounded by F. Here we go, there's that yellow, bounded by F, so that corresponds to this yellow portion of the curve. The x-axis, bounded by F, the x-axis, that was the orange, so that was the orange right here, that x-axis, and the lines, they're vertical lines. X equals A and X equals B. And we'll highlight that in blue. So there's the blue, the blue. So that area that's bounded by the function f of x, the x-axis, and the lines x equals A to x equals B can be determined by finding the definite integral evaluated from a to b of f of x dx. And I'm going to show you exactly how to do this. Let me rewrite this. It's good practice because we're going to label some things here. We're going to add to our vocabulary. Area is equal to, we know that this is the integral sign. We've got our lower limit of integration. That's called your lower limit of integration. So it's going to be important for you to know this vocabulary so that when we talk about the lower limit, the upper limit, you know exactly which is which. And then B is going to be the upper limit of integration. So we'll have our lower value that's along the x-axis, that's going to be A, and then our upper value, the higher value along the x-axis, that's going to be B. So let me give you an example. We're going to evaluate the definite integral of 2x dx evaluated from x equals 0 to x equals 2. Now, I'm going to draw a picture of it because it's going to help us get an idea of what's happening here. 2x dx is inside the integral. That means our function is 2x. So 2x is going to look like this. I want to do this. Here, let's label our 1, 2, 3, 4. 1, 2, 3, 4. Okay, so 2x, y equals 2x, has a y-intercept of 0, a slope of 2, so up 2, right 1, up 2, right 1, up 2, right 1. So there's our f of x. So I'm going to write y equals 2x right there. And then we've got from 0 to 2. So from x equals 0 to x equals 2. So you can see that we have this triangular area. That we're going to be finding. And if we do this just using geometry, area, which is equal to the integral of 0 to 2 of 2x dx. The integral from 0 to 2 of 2x dx. This just means find the area under the curve. Find the area under the curve. Sometimes we're going to do this mathematically using arithmetic, and sometimes we're going to do this, or algebra, and sometimes we're going to do this using geometry. And I'm going to demonstrate for you the geometry way first, and then we'll move into the algebra. So this just says find the area under the curve y equals 2x from x equals 0 to x equals 2. That's exactly what this integral means. So area, we know, of a triangle, it's a triangle, so area of a triangle is equal to 1/2 the base times the height, and the base is a length of 2, and the height is a height of 4, and 1/2 times 2 times 4 is equal to 4 units squared, right? 4 units squared. Now, it said evaluate the integral, so when we evaluate the integral, we're just going to box the value of 4. If it asks us to specifically find the area, then I'm going to label my units squared. But I want to show you that it's equivalent. The 4, the numerical value, is going to be equivalent. So let's just practice doing this geometry, and then we're going to do these problems using some calculus and algebra. So here's for you to try. Okay, you should have from 0 to 3, and then going as high as 12. And this is y equals 4x. And you can do that by putting a 0 in for x, getting a 0 out, putting a 3 in for x, getting a 12 out. You know that your base is 3, your height is 12. So the area is going to equal 1/2 the base times the height, half of 3. You could do it that way, or you could say half of 12, or you could say half of 36. I say half of 12 is 6. 6 times 3 is 18, and we get a value of 18 for our answer.